Shri Rajalakshmi Prakashan published. A textbook on fundamentals of agronomy 1. Authors: Dr. D. N. Jagtap, Dr. P. B. Pawar, Dr. U. V. Mahadkar. Chapter 3. TILTH, its definition, characteristics and ideal tilth, modern concepts of tillage, minimum, zero and stubble mulch tillage, importance of puddling. Tilth is a physical condition of the soil resulting from tillage. Tilth is a loose friable, mellow, airy, powdery, granular and crumbly condition of the soil with optimum moisture content suitable for working and germination or sprouting of seeds and propagules, i.e., tilth is the ideal seed bed. Characteristics of good tilth. Good tilth refers to the favorable physical conditions for germination and growth of crops. Tilth indicates to properties of soil viz, the size distribution of aggregates and mellowness or friability of soil. The relative proportion of different-sized soil aggregates is known as size distribution of soil aggregates. Higher percentages of larger aggregates with a size above 5 mm in diameter are necessary for irrigated agriculture, while higher percentage of smaller aggregates, 1 to 2 mm in diameter, are desirable for rain-fed agriculture. Mellowness or friability is that property of soil by which the clods, when dry, become more crumbly. A soil with good tilth is quite porous and has free drainage up to water table. The capillary and non-capillary pores should be in equal proportion so that sufficient amount of water and free air is retained respectively. Types of tilth. Fine tilth refers to the powdery condition of the soil. Coarse tilth refers to the rough cloddy condition of the soil. Fine seed bed is required for small seeded crops like ragi, onion, bersine, tobacco. Coarse seedbed is needed for bold seeded crops like sorghum, cotton, chickpea, lablab, etc. Modern concepts in tillage. In conventional tillage, combined primary and secondary tillage operations are performed in preparing seed bed by using animal or tractor, which cause hard pan in subsoils resulting in poor infiltration of rain water, thus it is more susceptible to runoff and soil erosion. Farmers usually prepare fine seed bed by repeated plowing when the animal of the farm is having less work. Research has shown that frequent tillage is rarely beneficial and often detrimental. Repeated use of heavy machinery destroys structures, causes soil pans and leads to soil erosion. Moreover, energy is often wasted during tillage processes. All these reasons led to the development of modern concepts, namely the practices like minimum tillage, zero tillage, stubble mulch farming and conservation tillage, etc. Minimum tillage. Minimum tillage is aimed at reducing tillage to the minimum necessary for ensuring a good seedbed, rapid germination, a satisfactory stand and favorable growing conditions. Tillage can be reduced in two ways: by omitting operations which do not give much benefit when compared to the cost, and by combining agricultural operations like seeding and fertilizer application. Tillage can be reduced in two ways: by omitting operations which do not give much benefit when compared to the cost, by combining agricultural operations like seeding and fertilizer application. The minimum tillage systems can be grouped into the following categories. Point 1. Row zone tillage. Primary tillage is done with mold board plow in the entire area of the field. Secondary tillage operations like disking and harrowing are reduced and done only in row zone. Point 2. Plow plant tillage. After the primary tillage, a special planter is used for sowing. In one run over the field, the row zone is pulverized and seeds are sown by the planter. Point 3. Wheel track tillage. Primary plowing is done as usual. Tractor is used for sowing. The wheels of the tractor pulverize the row zone in which planting is done. In all these systems, primary tillage is as usual. However, Secondary tillage is replaced by direct sowing, in which sown seed is covered in the row zone with the equipment used for sowing. Advantages, especially in coarse and medium textured soils. Improved soil conditions due to decomposition of plant residues in situ. Higher infiltration caused by the vegetation present on the soil and channels formed by the decomposition of dead roots. Less resistance to root growth due to improved structure. Less soil compaction by the reduced movement of heavy tillage vehicles. Less soil erosion compared to conventional tillage. Disadvantages. Seed germination is lower with minimum tillage. More nitrogen has to be added as the rate of decomposition of organic matter is slow. This point holds good only in temperate regions. Contrary to this, in tropics, minimum tillage recommended to conserve organic matter in the soil. Nodulation is affected in some leguminous crops like peas and broad beans. Sowing operations are difficult with ordinary equipment. Continuous use of herbicides causes pollution problems and dominance of perennial problematic weeds, weed shift. Minimum tillage can be achieved by the following methods. Zero tillage, no tillage. In this, new crop is planted in the residues of the previous crop without any prior soil tillage or seed bed preparation, and it is possible when all the weeds are controlled by the use of herbicides. Zero tillage is applicable for soils with a coarse textured surface horizon, good internal drainage, high biological activity of soil fauna, favorable initial soil structure, and an adequate quantity of crop residue as mulch. These conditions are generally found in alphasols, oxisols, and altisols in the humid and subhumid tropics. Zero tillage is an extreme form of minimum tillage. Primary tillage is completely avoided and secondary tillage is restricted to seedbed preparation in the row zone only. It is also known as no tillage and is resorted to places where soils are subjected to wind and water erosion. Timing of tillage operation is too difficult and requirements of energy and labor for tillage are also too high. Weeds are controlled using herbicides. Hence, it is also referred as chemical tillage. There are two types of zero tillage. Point A. Till planting. Till planting is one method of practicing zero tillage. A wide sweep and trash bar clears a strip over the previous crop row and planter opens a narrow strip into which seeds are planted and covered. Here, herbicide functions are extended. Before sowing, the vegetation present has to be destroyed, for which broad-spectrum non-selective herbicides like glyphosate, paraquat and diquat are used. Point B. Sod planting or sod culture. Sod refers to top few centimeters of soil permeated by and held together with grass roots or grass legume roots. Planting of seeds in sods without any tillage operation is known as sod culture or sod seeding. Usually legumes or small grains are mechanically placed directly into a sod. Advantages. Zero-tilled soils are homogeneous in structure with more number of earthworms. Organic matter content increases due to less mineralization. Surface runoff is reduced due to presence of mulch. Disadvantages. Higher amount of nitrogen has to be applied for mineralization of organic matter in zero tillage. Perennial weeds may be a problem. High number of volunteer plants and buildup of pests. Stubble mulch tillage or stubble mulch farming. Soil is protected at all times either by growing a crop or by leaving the crop residues on the surface during fallow periods. Sweeps or blades are generally used to cut the soil up to 12 to 15 centimeters depth in the first operation after harvest, and depth of cut is reduced during subsequent operations. When large amount of residues are present, a disc-type implement is used for the first operation to incorporate some of the residues into the soil. This hastens the decomposition but still keeps enough residues on top soil. Two methods for sowing crops in stubble mulch tillage are. Point 1. Similar to zero tillage, a wide sweep and trash bars are used to clear a strip, and a narrow planter shoe opens a narrow furrow into which seeds are placed. Point 2. A narrow chisel of 5 to 10 cm width is worked through the soil at a depth of 15 to 30 cm, leaving all plant residues on the surface. The chisel shatters the tillage pans and surface crusts. Planting is done with special planters. Disadvantages of stubble mulch farming. The residues left on the surface interfere with seed bed preparation and sowing operations. The traditional tillage and sowing implements or equipments are not suitable under these conditions. Conservation tillage. The major objective is to conserve soil and soil moisture. It is a system of tillage in which organic residues are not inverted into the soil such that they remain on surface as protective cover against erosion and evaporation losses of soil moisture. If stubble forms the protective cover on the surface, it is usually referred to as stubble mulch tillage. The residues left on soil surface interfere with seed bed preparation and sowing operations. It is a year-round system of managing plant residue with implements that undercut residues, losses the soil and kills the weeds. Advantages. Energy conservation through reduced tillage operations. Improve the soil physical properties. Reduce the water runoff from fields. Main field preparation. Tillage operations are generally classified into two: preparatory cultivation and after cultivation. The preparatory cultivation or tillage is operations that are done before the cultivation. This preparatory cultivation is generally called as main field preparation. The main field preparation involves three processes, that is, primary tillage, secondary tillage and layout for sowing. Some of the important primary tillage implements are country plough, mold board plough, disc plough, chisel plough, etc. Cultivators and harrows are generally used for secondary tillage purpose. However, in practical means, the first two, primary and secondary tillages, may not have any key difference since both operations are mainly carried out with same implement. Country plough and cultivators are used for both the purposes. After thorough ploughing, the field modified into suitable way for planting such as ridges and furrows or beds and channels or pit according to the need of the crops. Such field modifications are mandatory for better crop production. Puddling. Puddling of some heavy textured soils leads to an increase in total soil volume and a decrease in bulk density. This is due to the destruction of aggregates and the corresponding loss of interaggregate. Those soils in which the clay fraction disperses when the soil is worked wet form a random gel-like structure of the soil particles. The microaggregates are destabilized by the puddling. As water dries up, the soft puddle soil will tend to harden. Puddling causes partial dispersion of clay particles, which releases sufficient clay to fill many of the pores between the structural units, will be sufficient to create a characteristically puddled structure. The soil surface layer is made dense and compact. Eventually, the porosity of this surface layer is reduced by the infiltration of muddy surface materials. Then the important entrance channels to deep soil are closed. The soil profile material can no longer absorb air freely. Wet system of rice cultivation needs puddled condition, which involves ploughing of land in moist condition. The lands are ploughed and reploughed, with planking after each ploughing to bring the soil to a fine puddle condition. The whole of the upper layer of the soil should be in this smooth, soft, muddy condition, permitting the roots to ramify freely in the medium without being obstructed by hard layers. In the puddled soil, water is retained in the field. For rice crop, it is important to maintain standing water in the field as rice is semi-aquatic crop. Puddling helps in the retention of water so that rice can be grown successfully on puddled soil. Advantages of puddling. Less power required in tillage. Easy in transplanting rice due to soft mud. Plants are pushed into the mud with thumb and forefinger. Weeds are controlled by puddling. Buried weeds in the mud do not come out easily. Loss of water by percolation is reduced because of structure-less soil and the formation of tillage pan. Increase in availability of nutrients, especially phosphorus, iron and manganese. Disadvantages of puddling. A large quantity of water is required for puddling the soil. Soil structure is destroyed. In paddy field, other upland crops may not grow well due to structure-less soil and presence of tillage pan. Because of absence of air in the paddy field, toxic substances like hydrogen sulfide, ferrous oxide, etc. are formed. Loss of nitrogen, denitrification, is also occurred in water-logged paddy field. Root development is poor.
We politely request, please like, share and subscribe our channel Sri Raj Lakshmi Publication.